And we're live. Welcome to Swarms AI Expo, day number 2. Today we have Kendi Kemo, and Kendi Kemo is the lead World Resource Institute Africa's Data Lab. That's a mouthful. He oversees the strategic development and management of geospatial platforms, including Forest Atlases, Energy Access Explorer, Map Builder, and Africa Cities Watch. Global Forest Watch as well, right?
Yeah.
Okay. Kendi provides expert technical leadership across the continent, supporting the World Resource Institute teams with the implementation and maintenance of these platforms. He leads the design and integration of critical infrastructure, software, and cloud services, leveraging technologies such as AWS and Esri to optimize project outcomes in areas like forest management, urban planning, and Global Forest Watch. So, with that, Kendi, we're going to share your screen, and we're very excited to learn from you.
Thank you so much, Joachim. Hi, everyone. My name is Kendi. Like Joachim said, I'm already sharing my screen. If you see my screen, is a situation about Africa, not inside Africa.
Kendi,
Yeah.
I think we're just seeing the browser. I don't know if you shared the PowerPoint screen.
Oh, let me just share again. Windows. Oh, entire screen. Okay. Do you see my screen now?
Yes, sir. Yep, now we see it. Perfect.
No,
Perfect.
it's okay.
Yes, sir.
Okay. Okay, let me come back. If you see my screen, is my first slide is a situation about not entire Africa, but the discussion about Africa. You have a dry land somewhere in Africa. There you need to restore. You have another places is a savanna and secondary forest, and far you have a forest. How to preserve this environmental situation? How this environmental can protect about our climate? That is the first key question go to answer during this presentation. How AI and data collected for the field can work together to protect it? Then for this one, for this slide, you go to integrated field data and AI to unlock finance climate in the Congo Basin forest. As Joachim said, my name is Ken Kendi. I'm a lead of Data Lab Africa at WRI. More working on geospatial technology like AI, large model language to sustainable resource management. I also help the government to make the decision based on data. Okay. WRI is an NGO. How we are working in Africa? We are leveraging technology and AI for erasing natural resource management in Africa. We're going to take the case of forest carbon sequestration in Congo Basin. Using combined NCG data and intelligence artificial to unlock the climate finance. Our agenda today going to be talk about a bit about what the WRI is doing, what you offer, how you're working, forest and AI to unlock finance. What's our constraint? What's our solution? What's the use case? Because if you build some solution without use case, it's not a solution. What's the conclusion and perspective? What next? Let's start with one quiz. By 2015, you need like more than 200 hectares of cropland in the world. 400 about pasturage land, and you go to have a urban expansion like 18 million hectares. With this big extension about cropland, pasturage land, urban, how to manage about, at the same time, you have to protect some area, 30% by 2013. You need zero deforestation. You need to restore 600 million hectares by 2015. It's a big contradiction. You need something and you need the opposite. That's the idea that we have to work in Africa, help the government to build a solution, because Africa is a country of solution, especially for Congo Basin. That's why we are working in WRI in different sectors. We have Aqueduct about water risk because it's important to know about water flow. You need about climate watch. We have Global Forest Watch to monitor about our forests. You have a apps like Global Forest Watcher is apps to go to on the field without internet. You need Energy Access Explorer and also Open Timber Portal. Then you see you start on water, climate, forest. All the national resource is very important for us to preserve. Then you have to fight about maintaining everything and monitoring everything. Then our portfolio is the same slide you see before. You build a platform for action for the community because you have to start by the community, work close with the community because they're facing different challenge day by day. You have to work with the government because they have to take a decision based on the data. You have to work with a company to say deforestation is not good, but that's another solution to fight against deforestation. If we deforest today, you have to restore tomorrow. How to work, how to engage the government, how to engage a partner. That's how you're working with your platforms. You also involve the journalist because if you do some work and journalist is not involved, it's going to be difficult to communicate to other one. After that, we have open data. You share our data, you create the data and you share the data to everyone to see, okay, do we have a good data? If not good data, you have a feedback for different new users. And also need a robust infrastructure. You have a lot of platforms work on the cloud. You have a cloud service, you have another application, everything. You need to have a good infrastructure to develop this. How our data and technology impact the human system every day? The first image about is about the NGO peoples. They talk about deforestation. They try to protect their lands for the investor like company, like private sector, everyone's. They try to protect the land. That's the first platform you have to have Forest Watch to protect your land. The second one is energy. You cannot do anything without energy. How to know this place need energy? How do this part of country have a stress in terms of energy? Then energy planning is very important. This image was taken in DSC. What about our air? We are respire every day. You have Canary air to measure quality of your air. You have a application in Kenya, Latin America, how you have developed this one. This is how your technology is used day by day in different sectors. This image you see is a Central Africa Republic in Central Africa, in Africa. There's a logging company. They open the roads, like you see the main road, and they cut the trees. You see every day they cut new trees. How to monitor this one? The logging concession is very big for the concessionaire to understand what is going on because when you are logging in the east part of your concession, someone are cutting in the west part. How to the government to make sure that concession is not doing their work outside their boundary. Then you use the satellite image and many other stuff to monitor this one. The second impact about restoration. Every day you say you are restore place. How to track, how to count. The restoration is very important. What you are doing. Then you are using and AI to detect, to do like a tree counting. The first image you see inside the cities, because forest for cities is good. Restoration like agro-industry is also good. But how to track, you say after 10 years, you restore 1 million hectare. How to know that? How to count the tree inside the restoration? Then you develop another tools based on AI and geospatial to count the tree you are restoring. As you see, you can count like 1,006,000 tree in 3 minutes. For this image, if I show the next one, you can count the tree inside this space. This tool is very important for the East Africa country or East Africa region in Africa because they don't have a deep forest. They don't have the tree outside the forest. When you restore or you can count what they are doing there, then our tools, our technology, our geospatial and AI is very important for us. You have a tool for for the person who have a background in GIS you have a background in IT, you have a certain background to understand some things. What about the people who don't understand data like GIS platform, like AI, they want us to use? You are building a geospatial like ChatGPT for our forest, for monitoring of forest. You have put our API, all the API come for Global Forest Watch on our own ChatGPT to allow everyone, everywhere to just type a request and get answer and see the answer. You can see how many hectare forest loss in one country like Madagascar this year on our own ChatGPT, based on our own API. You can give it the result. For the decision making is very important. It's a very good data. It's accurate data because it's based on our platform. What's the key driver in terms of deforestation inside the Congo Basin? This type of analyze you can do on the or ChatGPT. This too is very important for the government because when the government go to the different meetings, political meeting or decision making, they have a good they're supposed to have a good data. You cannot just spend like 3 hours, 4 hours to produce good data. Based on AI, you can have a good data. That's why you develop this platform. The first part is what WRI can offer. Let's go deep dive in terms of one project we are doing in Congo Basin, with a partnership with a different university in Cameroon, in Kinshasa, and Lacuna Fund. The project have implemented two parts in Cameroon and Congo, Democratic Republic of Congo, like you see on the image. You have one here in Cameroon, other took place here in DRC. You have to evaluate the forest inventory because if you want to know how many carbon the forest sequestrate or carbon removal inside the atmosphere, you have to evaluate your forest first. That you are doing now using the remote sensing, AI, and ground truthing because you're going to collect data for the ground, data for remotely, and make a model to have this solution. If you see my screen on this side, this is the forest. What about the forest? If you try to do forest inventory today, you have a forest like this with a carbon sink. You will take the forest. You have a loss like due to the fire, the tree holes, due to deforestation, you have a carbon removal, like carbon emissions and carbon sinks. That is the life of the forest. The carbon emission, carbon removals. How to evaluate this one? You cannot just evaluate based on satellite image. You need also to go to the grounds because satellite image cannot evaluate how many tree cover loss you have in the 2 hectares based on satellite image due to the fire. It's because 2 hectares is sometimes very small, but based on the field mission, you need to understand what's happened there. That's why very crucial to mix the two to have a good data. Why we do these things? You have a lot of control in Congo Basin. There are few open data about the forest inventory in Central Africa. Most of the data is produced by the project. At the end of the project, the data is dead. How to engage the government, how to engage the university to work together to deliver a model, then go to share and train the ministry to do that after that. Sometimes where the model exists, where the data exists is a private one. It's inside one computer, you have to pay something to do that. And this data is not available for decision making. When you plan to develop a solution, put this solution like open source, do the solution with the government staff and the university for different country, and see what next for this one. We also have a lack of information about projected tree species over the time. You know, in forest is like animals. Some species they are dead because due to a lot of cutting type of species of forest. We want to do some projects on for the next 10, 20 years, then 50 years. What's happened in terms of forest species composition over the time during this project? Then the main objective is to understand and evaluate the amount of and the rate of location of carbon accumulation in the standing, in the regeneration tropical forest in Congo Basin. Also, it's very important to mapping these things, to have maps because map is for the decision making. When you talk about number without maps, they don't understand where you are going. If I say that you are losing like the carbon emission is like one stadium or 10 stadium or 100 stadium, you have a good scientific approach because you are mapping with something you know. It's possible to map these things and help the government to understand what's happening. For the solution, you put like 65 plots in DRC and Cameroon, then 10 in Cameroon and 55 in DRC, Congo. DRC is Congo Democratic Republic. For this 10 plot, they go to measure. So they also do some measurement on the ground. Also do the ground shooting, go to field survey to collect about information of different species on type of forest. After this collection, we are working with University of Purdue, go to build a database about what's going on on the forest. Then you're going to develop a models with AI to know, okay, this matrix is going to help us to match what is going on in the forest remotely and try to predict for the next 10 years, for the next 60 years, what's happening, and also evaluate the carbon deforestation. That's at the end, the result go to be very easy because they go to have a decision maker in different countries. Okay, today in terms of carbon sequestration, in terms of carbon finance, the Congo Basin can ask this amount or can manage this one based on our results. Congo is very big. You see, the map is produced by 1 kilometer resolution maps. It's very big maps. You can do that day by day. You need the model to do that to develop this one. What's the community engagement at the end of the project? It's good for the Cameroonians, forest and wildlife, the Democratic Republic of Congo, the two universities, one in Cameroon, one in Congo, the timber company. We have a lot of timber company do maybe destroy the forest. You want to say, okay, based on our analyze, this is the result you have. Please stop do this to preserve our nature, to provide stability for tomorrow. Even for scientific education is very important tools because you have the first model for the two first country. But what about the country don't have forests? You just have savanna. Is it this model can be applicable for this type of country? This is scientific engagement for the next step of our project. In terms of use case, I already said for the use case. Then today we are doing for two countries, but we are planning to do for many other countries for AI. Use cases. Okay, in terms of conclusion and perspective, you want to scaling and replication this approach. Extend for the South Africa and other tropical forests like Brazil, which Amazonia, like Indonesia, how they're doing, is it the same, is it a different one? Make sure capacity buildings, engage a government institution like government and other government parts to be at the beginning of the project, understand what they're doing, take the lead, even to build their own models to be replicable. Because if you develop the project job by the university and the WRI, you're going to be less information for the government. How to engage the government on this one. About AI, about machine learning, you can do some projection for the next, in terms of dynamic of carbon dynamic for the next 20 years. Thank you so much, Joachim. I don't go deep on the technical aspect because I want to show the use case first, but I'm open to give more in terms of what the model we are going to develop, what the approach we're going to use to do that. Then for the
Yeah.
next question, I go to answer. Thank you.
Quick question. It says right there low battery. I don't know if you want to plug in your laptop before
Yeah.
you get unplugged.
Yes, let me join just 1 minute. I want to take my charger.
Yeah, no problem.
Thank you.
We'll just give Kendi a minute. Excellent presentation. Yeah, it's a curiosity to be able to materialize data into an asset and use it to make decisions around how to manage the resources. Clean water, agriculture, all these things, they're not easy to come to, and we deeply need it as a society to survive. Hmm. Hello?
Yeah, sorry,
Oh,
I'm back. I'm here.
yeah, so I wanted to follow up with you with a few questions. So, in the presentation, you said good data is foundational, good data is key, and you also say, as frequently data scientists and people that work with machine learning models understand, either the good data is private, so it's not something that you can share publicly to reproduce results. Even in academia, good data, once it's used and produces a model, it's no longer maintained, right? It's kind of used and
Yes.
thrown away. So how do you think we can support open access to good data that is not dead and actively maintained?
Yeah, that's a good question. It's a two way to answer. But based on my way, the first thing is I think we are working for the government. We are working for the nature. We are going to preserve our future. We are give the support to the government. I help the government to be independent. Then you go to produce the first data with the government and make data available. You go to give the technology to the government to do the same things for the next year. We are lucky this year a grant to do that. But we are going to demonstrate to the government the same amount of money they spend to have like some license, very expensive. They can use the same amount to buy the storage to store the model they are built for the next year and make it open. That's the first approach, or how we are working in WRI with the government. The second one, based on our question, is based for the company want to do benefit profit. Then it's depending on which part of the river or the river you are. Then for me, for the government side, you help them to be independent because they monitor the forest. They have a lot of grants for the log company and different things. They can manage. Yes.
So you're saying
Over.
if it's essentially funded by a um, public organization, entity, or nonprofit, making it open makes it better because other people can access it and benefit from it, and there's no.
Yeah. They can make it better. You have a lot of students. You need some data for the research, for the PhD, for the masters. And the government data is official data. It's supposed to be always the best one.
Hmm. We have another question
But if
here from. Oh, sorry. Go ahead. No,
yeah, please
please.
go ahead.
Oh,
Okay. If,
please.
let me go
Sorry.
first. If the ministry tries to have a good data, they will always go to be like a good example. And also, is the forest, like you say, sometimes forests have a lot of concessions, you have a lot of stuff, you can generate the money. It's not because they are selling some data, they go to make them poor. Then for me, it's like government data is not always critical data, it's not sensitive data like inventory, like carbon sequestration. They're supposed to be open. They have a support, is IT staff. They don't need to sell data. That's all for me.
We have another question here from Niraj. She's saying, how about using machine learning models for optimizing the restoration like using timber from a particular region having less carbon consumption and selecting location alternatively without haphazardly destroying the place at once. So how do you sustainably consume
Can you
resources?
come again with the question?
How do you
Can you
leverage
come
machine
again with the question?
how do you leverage machine learning models to responsibly and sustainably consume resources?
Okay, good question. In terms of restoration, I think it was a question.
Yeah, optimizing the restoration of like forests and natural yeah, natural production of wood.
Yes, okay, good question. Initially, for the restoration case, it must happen on the dry country in East Africa, in the West Africa, the north part of West Africa. We restore a lot of this, a lot of area there. You're working at the landscape level, first things, and to improve your models, you need to have a baseline data first to like a first input. What's the situation like at T1? Restoration takes time. It's not like after 3 years, 2 years, you can see the result. Sometimes after 5 years. They're able to build your models like with data from T1, like first years, the, the two next years. They have to be patient to build this model because it's like take time to evaluate if restoring is doing well or doing bad. That's the first thing. The second thing, you have to build your model to count the trees. They're going to take the data outside the place you restore to like input models to understand how the tree is looking inside your models and bring it back to the previous one. That's all.
Okay. So how do you monitor to make sure that you're not over harvesting wood or taxing specific natural resources? Like you said, you when you plant trees, you have to give it a 3 to 5 window period to see if the trees stay and they integrate into the environment, or if they don't stick. But what about the consumption of those resources?
What about consumption? Okay. About other resources like except forest or
Yeah, how do you make sure people aren't just consuming all the wood?
oh, okay, good question. We are doing to like we do in East Africa. You work with the association. They plant the tree, they monitor the tree. After 3 years, they have to do the first step of evaluation. Because sometimes you plant the tree today, after 2 years, everything was destroyed by the animals. That's what it's not the IT, not the machine learning or something to do that. You have to
No, you're
find a good way
monitoring.
to
You're
protect.
you're monitoring, but you're monitoring the environment. You're monitoring the state of the things. But
Yeah.
do your models, do your recommendations then inform these associations to protect or enforce certain policies to retain the health of that environment?
Yes. Also,
Okay. Um, any other questions in the crowd? I mean, for me personally, I'm just fascinated that you are enabling so many different teams across Africa, across a broad range of use cases. How do you manage this portfolio of different activity?
no, I'm not managing all the portfolio for different activities. Different activities have their own managers. In terms they need some data improvements or data strategy, they call me to work with them because I better understand what is going because I start working in the forest before go outside or like IT. They know what is going, but not like day by day do like monitoring, but a bit in the part come and give them the support. As you see on the picture is a forest monitoring in terms of mining in forest in Cameroon. You deliver a training to the Ministry of Forest to monitor and do the trainer trainings. You train the trainers, even the ministry. After 2 trainings, I'm not involved because they have a lot of trainers to do the same training before me. They're
I
like
see.
most of the sharing capacity. Yeah.
I see. Okay. Well, Kendi, thank you very much for your presentation.
Thank you
We're going
too.
to take a brief intermission, and then we're going to be back with the next presentation. So stay tuned, and we'll see you in about 9 minutes.